Hello, everyone. Welcome back. We're going to continue with our material as far as digestive system is concerned. One of the last things we were mentioning as far as this unit, we were talking about the beginning of the gastrointestinal tract, or the alimentary canal, as we call it, the mouth, the oral cavity, as more anatomically correct. We mentioned a lot of stuff here as far as like the salivary glands and the purpose of saliva, as far as chemical digestion is concerned. We mentioned how the more physical or mechanical part of digestion is involving the teeth and the tongue to form this food ball that's easier to swallow. Then we talked quite a bit about some accessory information, especially relating to like the different types of teeth. I just think it's pretty interesting, as far as evolutionarily speaking, why we have these sets of teeth and how we compare to other animals. Okay, let's continue where we left off. So, the pharynx. We learned that structure back in respiratory system because it's the same exact structure in digestive system. It is simply the throat. If you remember, there were three distinct regions of the pharynx. We had the nasopharynx, which connects to the nose. We have the oropharynx, which connects to the mouth. And then we have the laryngopharynx, which connects to the larynx. That's just more specific detailing. That stuff we learned back in respiratory. It's just more of a review than anything else. But if you remember, towards the bottom of the pharynx, where the larynx starts to begin, we have that epiglottis tissue. I like to call that the gatekeeper. It helps to open and close accordingly, depending on what is moving through the throat. So as we see here, a flap of cartilage that covers the trachea when swallowing, aka closes, is open during respiration to allow air to enter the trachea. So anytime you are breathing in or out, the epiglottis has to be open in order for things to travel down the trachea into the lungs. Whereas with the opposite situation, with the esophagus, we're going to notice that it must stay closed. Again, as we learned back in respiratory system, does it always stay closed? No. Many times where you are, let's say, drinking something and someone makes you laugh, or you're eating food too fast, you can create pockets of air that kind of get trapped in the trachea region, and that can cause like hiccups, that can cause slight, uh, you know, coughing just to get out anything that might be stuck in there. Not necessarily something as violent as choking, which could obviously still happen if it's serious enough. So here we see a video that would be a good idea on your side to watch. It's just a video showing us what peristalsis looks like. Peristalsis is the involuntary waves of muscle contraction. So literally, if you've ever, all of us have gone to the beach before. We live in Florida, right? You see the waves crashing in on the sand. That's the method, that undulating motion of up and down, up and down. That's the method that our smooth muscle moves in. Hey, that's a word we learned a couple units back when we were in quarter 3 when we discussed the different types of muscle. We mentioned how we have smooth muscle, cardiac muscle, and skeletal. Yeah, we spent a lot of time talking about skeletal muscle back then, but now we get to bring up smooth muscle. Smooth muscle lines a lot of these internal organs, including the digestive system, and it helps to move everything in a very slow, methodical process. So again, not a bad idea to pull this video up on your time, just so you get a chance to see what peristalsis looks like and how it moves everything from the throat, truly, all the way down through the body. Next. So this is the tube found behind the trachea. So you don't necessarily feel this, although because it's so close and parallel to the trachea, when you swallow food and liquids, you do feel that same swallowing process. So it's not like it's so far off from your body that you can't tell what it is. A common nickname that you don't really hear too much nowadays is the gullet. That's just a nickname used to describe the esophagus. It is the passageway to the stomach. Always on the dorsal side of the neck. I would make sure we are good with that. So I'm just going to underline this a little bit here. So always on the dorsal side of the neck region. Remember, ventral is front side, dorsal is on the back. Think dorsal fins for like sharks and dolphins. So it's always on the back side of the neck. Trachea is on the ventral side, as we mentioned earlier. So just be good with that overall. Here we get a great view, like a side angle cut view of the upper digestive system and the upper body for the most part. So again, we see some things that we are familiar with, right? You see the nasal cavity, which of course is going to be filled with mucus and nasal hairs, and all that stuff that we learned back in previous systems. We see the oral cavity, which inside the oral cavity, we're going to have those salivary glands, the teeth, the tongue, which you see in its pretty large structure. Now, what I like about this is that it shows us when you've chewed your food enough and when you've used the tongue properly, you're going to form this food ball, the bolus, as we call it. So the bolus starts to travel down the back of the mouth or the oral cavity. As that happens, it starts to hit the pharynx. When it passes through the pharynx, you'll notice the epiglottis. It's currently up in this picture, indicating air is traveling in and out. But what we're going to see is that the epiglottis will shut in this picture right here. When it shuts, it prevents any of these food particles from traveling into the trachea. It goes down the dorsal side, as we mentioned. And then this picture on the right does an amazing job of showing us how peristalsis works. It is literally the squeezing process of moving things downward. Yes, gravitational forces definitely help with the movement of food. But when we get to the small intestine, and especially the large intestine, we'll notice that gravitational forces don't always help when it comes down to moving things in one direction. So you do need a little bit of assistance for this. So that's what peristalsis helps with. It helps to relax the muscles and then contract and squeeze it until eventually that food ball makes its way to the stomach. All right, speaking of the stomach, we're able to see that the stomach is a rather large structure. Like I mentioned, it's about the size of a football or sorts. Here we can see a great picture showing us what it would look like in like an x-ray view. So the stomach, its whole job, it stores food and breaks down food. Now, by storing food, we don't necessarily mean storing food in like a freezer. This is more like you're storing food very temporarily before you decide what to do with it and inevitably break it down even further. The methods of breakdown or the methods of digestion that it goes through is going to be both mechanical and chemical. What's the mechanical process? Well, your stomach likes to churn the food. What I like to think of is imagine a washing machine and you throw a load of laundry in there and you set it to like a slow or a low setting. It's not going to be tumbling as much because obviously if your stomach's churning that much, you're going to have an upset stomach. You're not going to feel good. But it is natural for the muscles that surround the stomach to kind of shake and vibrate the stomach ever so slightly in order to help move a lot of that stomach acid. So that's purely the mechanical side of things. On the chemical side, it's definitely going to be more of the stomach acid, which helps with ripping apart and breaking down proteins as fast as possible. Gastric juices, otherwise known as stomach acid. This converts your food ball into a new term. So remember previously, when you eat food, right, like hamburger is the classic example I like to use in this case. You eat a hamburger, you bite into it. After your mouth has done what it needs to do with it, you've now converted it from food into what we're properly calling as the bolus. After the bolus has traveled down the esophagus and has entered the stomach, you're then going to convert the bolus into what we call chyme. Chyme is when you've made it less solid. It is now becoming more and more liquid. You're really starting to rip apart its texture. The gastric juices is made up of two major compounds. There's more than just these two, but these are the ones I want us to be focused with. First of all, if you've taken chemistry, you should be familiar with what this formula is. HCl, hydrochloric acid. Hydrochloric acid is incredibly acidic. If you ever got hydrochloric acid on your skin, for instance, if left untreated, it could eat away to bone. It is very, very powerful. So the entire point of this is that it's going to help kill bacteria. That's great. As efficient as our cooking processes have become in the 21st century, and people are not getting nearly as sick from food anymore, nothing's perfect. It doesn't matter where you go to get your food picked up, or if you make it at home, you're still going to have remnants of something left over. Hopefully nothing serious, right, like salmonella, but most of the times there's still remnants. So your stomach acid helps to check for that and say, let's just nuke and destroy everything possible that could harm you. Is it perfect? No. Like I mentioned, there are some bacteria that sneak their way through the stomach. Take, for instance, salmonella. And again, as I mentioned earlier, hydrochloric acid helps to denature protein. So it helps to break down protein. If you remember when we did our macromolecule unit, we mentioned how proteins have 4 types of structures. primary, secondary, tertiary, and quaternary. The whole process of denaturing a protein is basically turning a quaternary protein, which is super complex, into eventually a tertiary, a secondary, and a primary. The smaller you make the protein, the easier it is to then absorb. Now, here's what we're thinking, right? Hydrochloric acid, we just mentioned how powerful it is, and it could eat away at skin. It's super, super acidic. Why is it then we don't have a massive hole in our chest where our stomach is? Well, it turns out, if you look at the structure here, the stomach has these grooves in it called the fundus. The stomach has a special lining that protects against its own acid. Perfect, no problem. But what we need to be careful with is that the stomach is the only area that can protect against that acid. Not to mention, this fundus, it can wear down. If you've had gastric problems for many years, the stomach lining starts to wear down, and the hydrochloric acid actually starts to affect the stomach itself and can possibly puncture the stomach. And obviously, that can be very problematic and painful. Not to mention, we mentioned how the stomach is the only area that's naturally protected. If stomach acid comes up through the esophagus, which, as we mentioned in the last video, is known as heartburn, the esophagus does not have that protection. You're going to feel it. It's going to hurt. So those areas are more sensitive. You do have a little bit of protective covering in the beginning of the small intestine, and not to mention you have a lot of enzymes secreted there to help neutralize this acid. So really, the area that's going to be most protected is going to be the stomach. Now, we see some other structures here, like the esophageal sphincter and the pyloric sphincter. If you remember in the last video, I mentioned how these sphincters are like muscular doors. They open and close accordingly in order to prevent things from going in or out. So for instance, when food has entered the stomach, this esophageal sphincter shuts. You do not want things going back up, right? On the other side, when food has entered the stomach, the pyloric sphincter also shuts to allow the stomach to digest a little bit. As soon as the stomach has done what it needs to do, this side is going to open, and then things will move into the small intestine and continue onward. Another major compound, which is an enzyme found in gastric juice, or stomach acid as we call it, is pepsin. The good news with these enzymes is that the prefix tells you a lot, right? Remember how amylase, we talked about it, it's in the saliva, helps to break down sugars because amylose is a type of sugar. Well, pepsin, pep kind of reminds me of protein. It sort of sounds similar, but pepsin helps to break down proteins. That's their entire job. So we have a special enzyme just to target proteins. So as we mentioned a little bit earlier, we have the fundus and the rugae, which are those large folds that you see. Literally, if you've ever taken a bath or you've been in a pool or the beach for long enough, in the water more specifically, and you get out and you see your hand is all wrinkly and everything, that is very similar to what the inside of your stomach looks like. We have this mucus lining, which we mentioned is designed to protect, which that mucus lining can wear down and can form ulcers. The good news is post 40 for most of us, sometimes 45, and maybe even earlier than 40, depending if you have a familial history of gastric problems, every single one of us have to start getting procedures done to make sure our health is good. What are these procedures? Well, they're endectomies and colonoscopies. Endectomy, we can talk about that one today because it's relating to the stomach. Endectomy is when you are given an anesthetic. You're not knocked out, but you're kind of like in a dream state. So you're kind of in between. You're given an anesthetic and they take a tube down the throat, and as they pass it through the esophagus, they reach the stomach. They do actually go a little bit into the small intestine as well, so it does go pretty far, but that tube has a camera on it, and it's literally like a remote control situation. But not only that, not only does it have a camera, it has like a lot of extra tools attached to it that kind of come out of it. So for instance, there's a little pincer, if you want to call it that helps to rip apart tissue. So for instance, if something looks weird, a gastroenterologist can say, like, I need to take some of this out, especially if it looks like an ulcer, and we're going to run samples on it, especially to prevent it, to make sure that it's not cancerous. There's little anesthetics that it can shoot out straight from the tube. Water can shoot straight from it. It's pretty cool. I've had a chance to see some of these procedures done in person. And if you get a chance to talk to a gastroenterologist for shadowing purposes, it's not a bad idea. Really, a really hands-on procedure that's done to really get a good view of the internal organs. But like I mentioned, every single one of us have to start doing this type of stuff, usually around age 40. And then typically it's every 5 years, maybe even every 10 years, depending if you're a healthy person, just to make sure that you don't have any sort of negative growth happening in these areas. Um, and then finally, as we mentioned earlier, we have those sphincters, which, as we said, are just going to be these muscular doors that open and close. Most are involuntary, some are voluntary. The sphincters found in the pyloric and the esophageal are involuntary. They will only open according to other stimuli, and the other stimuli in this case is food. There are other sphincters, especially in the urinary system and the reproductive system, that are voluntary, that you can physically control and think of activating. But we'll get to those when we progress a little bit further. Okay, so that's a good point. Let me just go through here real quick because we might as well talk about this is still stomach related. Here we're able to see a little bit more of the stomach with the outer covering that we mentioned. This is a much more zoomed in version of the stomach. These are the specific cells that secrete the stuff that I was mentioning. We don't need to get too crazy with that, but we have what's called chief cells and parietal cells. They're found deep embedded into the stomach. The chief cells help to secrete a compound that is going to inevitably make pepsin, whereas the parietal cells help to secrete hydrochloric acid. And as you can tell with this chemical reaction here, hydrochloric acid is required to help convert pepsinogen into pepsin. A little bit more chemistry, but just wanted to go over that real quick with us. All right, so that's where we're going to finish for today. Thanks for tuning in, guys. We'll go ahead and continue with this material in our next video.